So in this question, we're given a decay constant, which the rate constant is k is equal to 2.88 times 10 to the negative fifth inverse years. And so this unit tells us that this is first order. And so in order to deal with these half-life questions, we can use the first order half-life equation that you should either know or you can look up pretty easily. But the half-life is equal to the natural log of 2 over the rate constant. And so our first step in solving this problem is plugging in right here and finding out what the half-life is. And this is pretty simple. We get that our half-life is equal to 24067 years. Great. Now we're asked to figure out basically how we're given a period of time, and we have to figure out how many half-lives that is, and then use that to figure out what percentage we're going to get to. And so for this first one, we have 1,000 years over 24067 years per half-life is going to tell us that we have 0.0415 half-lives passed. And so what we do from here is, in order to get the fraction that is available at that time, like after that many half-lives, we take 0.5 to the power of the number of half-lives. Think about it like this. If you're going to forget this, remember that if we had one half-life, so 0.5 to 1 for one half-life, we would be basically saying 50% or 1/2. That's what we should expect, that after one half-life we get to 50%. If we have two half-lives, 0.5 squared is equal to 0.25 or 25%, which is also what we should expect. And so that's how we get to this formula. And either way, when we do that, we're going to find that our answer is 0.971, or 97.1% is remaining. And so then the rest of the questions are actually really simple. I'm just going to write out what we have is 0.5 to the number of half-lives, which is going to be, in this first case, 25,000 divided by our half-life, 24067. And when you do that, you'll get 0.486 or 48.6%. And then our last one, 0.5, we go to the power of 100,000 over our half-life, and that's equal to 5.6%.